That is a 10 ohm resistor. Okay, there are radio towers and cell phone towers near me. This is the resistance of a 10 ohm metal film resistor. Standard 4th watt. Okay. Now, the skin that I have is in mega ohms. My skin is in mega ohms. So are parts of my eyes, my lungs, my hair. It's in mega ohms. And we know that frequencies generate very low amounts of energy that are less than ionizing from cell phones and radio towers. So that means that they're quantum physical. They have to have devices that measure fractions of one charge, which is actually a change in resistance of the flow of current, which is a very sensitive little circuit. As you can see, 10 ohms would be oscillating in the decimal region if the frequency was strong enough. It would be oscillating. We know that it is creating energy changes in the 10 ohms, but my point is that 10 ohms is not sensitive enough to actually detect radio frequency changes. Much like your body isn't sensitive enough to detect radio frequency changes. But we do get oscillations occasionally from the changes in the radios around here. It's really slow. But if I was to use a piece of copper, just plain copper, on the end of that wire, a flat plate, the oscillations would be faster because there's less positive charge or something to pull away the resistance of the electrons or the charge of the electrons. So material is very, very, very nice aspect, but so is resistance over a volume or an area. Our bodies do not really have much problem with radio signals. We don't really worry about that so much, as long as they're in the radio frequency range. So they say that radio frequencies are somewhere between the size of a baseball and somewhere maybe even 30 feet in wavelength. Their wavelengths are rather large. That's why they don't oscillate as much. They're not as dangerous. A baseball-sized wavelength really has less chances of oscillating that resistor's resistance values by changing the amount of energy it has when current is flowing through it on the ohm scale. That's 200 ohm scale. It says that it's 11 ohms. Now, if I reduce the resistance, it will oscillate a lot faster. So that's how you filter it out. That's the kind of devices our cell phones and our computers use. Very tiny micro and nano components. To get that kind of a frequency out of it, you have to use conductors and things that are very sensitive, like radio circuits. And you can amplify and stage that amount of energy and also filter it. And then it can be digitized and turned into data.